Hello, my name is Diego, and I will delve into our physical experimentation case study on finding a mass for critical damping. Our main objective was to identify the theoretical mass that would induce critical damping in a fluid system reflecting a car suspension's dynamics. This balance is essential for systems like car suspensions, where rapid return to equilibrium without oscillation is needed. Our experimental setup involved a spring and damping fluid, maintaining consistency with previous experiments to keep the spring constant K and damping constant B the same. We calculated the necessary mass for critical damping and constructing the system to observe the phenomena. From earlier experiments, we determined the spring constant K to be 33.20 newtons per meters and the damping constant B to be 0.0666 kilograms per second. Using this, we calculated the required mass for critical damping as 33.40 milligrams and graphically demonstrated the critical damped oscillation. However, we found that the theoretical mass was too small for practical displacement, highlighting the challenges of translating theory to practice. This discrepancy arose from factors like changes in the damping material's properties due to environmental influences or characteristics affecting the damping constant B and the fluid's diminished damping characteristics, which failed to provide adequate resistive force for spring's oscillation. These findings underscore the necessity of aligning theoretical predictions with practical realities, highlighting the need for adaptable experimental setups. To surmount these obstacles, we consider using a liquid with a higher damping constant and a spring with a lower spring constant, aiming for a more feasible mass that could effectively dampen the system. In conclusion, our study highlights the complexity of achieving critical damping, where factors like the damping constant, spring constant, and mass intricately interplay. The challenges lies in aligning the theoretical critical damping mass with practical conditions, with practical outcomes, as too small a mass may not effectively influence the system's displacement. This insight stresses the importance of realistic modeling and testing in experimental physics. To bridge the gap between theoretical calculations and practical applications, future endeavors should explore a variety of damping fluids with different coefficients. Thank you very much.